Hi guys, welcome to your lesson on metric measurements. Your learning intention is to record measurements data in appropriate metric units, and you will be successful if you can accurately measure volume, mass, distance, density, and temperature in the correct metric units. So why have measurement standards, and what in the world are they? Well, measurement standards are an exact quantity people agree to use for comparison. That is the definition, an exact quantity people agree to use for comparison. And the measurement standards that we use today are called the SI system, System International, based in the French language. And this is the improved metric system that's used by scientists around the world. It's based on units of 10. So it's easy to convert from one unit to another within the same family. For instance, converting from centimeters to meters is fairly easy. You just divide by 100. Converting from kilometers to meters is easy. You just multiply by 1,000. So just remember that it's based on units of 10, not 100, not 1,000. Based on units of 10. We'll go through how to convert between units in class so that you get some practice with that. But every time you write down a measurement, I want you to remember that without a unit, it means nothing. Measurement has to be a number and a unit. So if I ask you to measure the width of your desk and you decide that it's about 34 what? Is it 34 inches? 34 feet, 34 centimeters. Let's use metric units, of course. Is it 34 centimeters? Is it 34 millimeters? You have to have a number. So make sure you use a number and a unit. Numbers alone means nothing. The next thing we need to talk about are the different units that we use for measurement. We're going to use several different measurements in labs, but mostly we'll be using these 4 measurements: volume, mass, density, and temperature. For volume, the SI unit is the liter. You can have milliliters, liters, and kiloliters as the most common unit for measuring volume. Mass is measured in grams, not kilograms. Kilograms is a form of grams. A kilogram is 1,000 grams. And if you think about it, a gram is about the mass of a paper clip. So 1,000 paper clips would be about a kilogram. To give you an idea, 1 kilogram is about 2.2 pounds. So if you know how much a pound weighs, when you feel a pound in your hand, a pound of mass in your hand, a pound of weight in your hand, then you can figure out what the mass of that thing is. It's about 2.2 pounds per kilogram. Distance is always going to be measured in meters. If I'm going to measure the distance between one side of my phone and the other, I might use centimeters. If I want to measure the distance from here to the other side of the school, I might use meters. If I was going to measure the distance from here to Gaston, kilometers. It just depends on what you're measuring as to what size of unit you need to use. And then the last thing on the list is temperature. Temperature, you might think Fahrenheit. When I listen to the weatherman on the newscast, I hear Fahrenheit temperatures. Like today, it was 88 degrees Fahrenheit. It wasn't 88 degrees Celsius, or we would have been in real trouble because that's really hot. Temperature in science is not measured in Fahrenheit. In science, we have to use either Celsius or the correct unit, which is Kelvin. Now, Celsius and Kelvin are the same size because the guy who invented the Kelvin scale used the Celsius scale as the base for his scale. The size of the degrees on the thermometer for Kelvin are the same size as the degrees for Celsius. The only difference is where it starts and where it stops. Kelvin actually has a 0. But it's actually negative 273 Celsius. That may be confusing, so just don't worry about that part. Worry about this. If you've got a Celsius temperature It's easy to change to Kelvin by adding 273. Now, we'll be coming back to this again later on this year because you're going to have to learn how to calculate Kelvin temperatures from Celsius temperatures for a lot of the labs we'll do with gases. Just remember, you're going to come back to this later on. Now, another type of unit that you're supposed to be able to measure in metric units is a derived unit called density. What's a derived unit? Never heard of that. A derived unit is 2 or more units combined. That could be something like miles per hour if we were talking about in the English system, or kilometers per hour in the metric system. That's kilometers and hours combined into one unit. The one that we're going to focus on right now is density. Density is measured in grams per milliliter. Well, grams, we just said, was mass. And volume was the liters, but we just said milliliters. Well, milliliters is a really small volume compared to a liter. So we're going to put grams here and milliliters here. We're going to do a lab with this, and then, but that will be after we have done a formative assessment on all that we've learned today, and we'll do a metrics quiz, which will include some basic conversions between meters and centimeters and liters and milliliters and those types of conversions, and then we'll do a density lab. I know that you'll enjoy the lab. You will measure the volume of an object, and then you will measure the mass of that object, and you'll use those to calculate the densities of the objects. I hope you have fun in the lab, and if you have any questions about anything that we've gone over today, just let me know. I'll be glad to help you out. Good luck on the lab, and good luck on all your assessments and quizzes.